assume, are here to review for Chapter 17. So here we go. Here's a test from 2022 to 23. We probably actually took the test in 23. But I've already removed some of the questions that we won't be getting into. So here's what's left over. This will look very similar to the actual Chapter 17 exam that you are getting ready to take. So let's walk through these. Number 1. In the circuit below, assume the battery is producing a voltage of 8 volts while the bulb is producing a resistance of 10 ohms. What must be the current traveling through the circuit? This just boils down to the calculation of current, which tells us that the more volts we have, the more current we have, the more resistance we have, the less current we have. So that goes on the bottom. We had 8 volts and 10 ohms. So then I'll reduce that down. What's that turn into decimal-wise? It'd be 0.8. Oh yeah, duh. 0.8. And this is current, so that would be A for amps. Or if you wanted to, you could write the whole thing, amps. That's not uncommon to see. On to 2. Assume you have a battery that produces 40 volts. There's our voltage. But you want your circuit to have a current of 5 amps. Now we're making sure we have a specific current. How much resistance do you need to include in your circuit? So I'm going to use this same equation, I is equal to V over R, but I'm going to solve it for R. Since R is on the bottom here, all I got to do is multiply that up and divide the I down. So we get resistance is our voltage divided by the current. So 40 volts divided by 5 amps. What's that give us? I believe that's 8. Got another 8 on the board. 8 ohms. Or if you want to be fancy, you can write that as an omega symbol, but I'm bad at drawing the omega symbol, so I kind of just like to write the word ohms. Number 3, the light above you, or the lights above you, are part of a parallel circuit. This is assuming you're reading this in the classroom. I don't know about your lights at home. But they're probably also on a parallel circuit. What is one major benefit of that instead of having them all in series? One of the major benefits is that if one of those lights goes out, the whole system doesn't collapse. So real quick, if I just drew this, here's a battery, here's one bulb, and here's another bulb in parallel. So if, for instance, this bulb on the end here broke or was removed entirely, the current could still flow through here continuously, meaning this light would keep on shining. That's the main benefit. Now, number 4, why is it so important to flip your house breaker off before repairing faulty electrical outlet? Repairing a faulty electrical outlet. Main benefit of that is so you don't become part of your house's circuit, because your house has a whole lot of electricity flowing through it and you don't want to be part of that circuit. So flip the breaker off, turn the electricity off essentially, and then you should be safer to do what you need to do. Although I do recommend, and this is speaking from experience, if you're about to do some electrical work, flip the breaker and then wait for a good chunk of time to make sure any residual voltage gets filtered out, I suppose. Because some can be left over and you will get shocked. It may not end you like my little stick man here, but it will be unpleasant. Moving on to number 5. Back to calculations, it looks like. Assume you have a circuit with 50 ohms of resistance and you want the circuit to have a 10 amps of current. How many volts of voltage do you need? So we're looking for voltage in this case. As a reminder, the starting point current is volts over resistance. So if I want to get V by itself, I just multiply R by both sides. So those cancel, and I get an R over here. In other words, voltage is current multiplied by resistance. So in this case, we had a current of 10 amps, and we had 50 ohms of resistance. Multiply those together, we get 500 volts of electricity. You can just write that as a V, but I prefer to put volts because we have other V's in physics. Number 6, using our fancy physics terms, why does plugging in a second battery to a circuit make the bulb shine brighter? Fancy physics terms, I suppose we could go with adding a second battery increases the voltage, which leads to an increase in current, which then causes a brighter bulb. So an increase in voltage leads to an increase in current, which yields a much brighter bulb. Well, assuming you increase it by a lot. Number 7, sketch a circuit diagram that includes one battery, one switch, and 2 lamps in parallel. Well, I already did this, so here's my battery. I'll put my switch up here, just to keep it simple. Here's one bulb, and then since I want the other bulb to be in parallel, I'm going to give it its own parallel path. So these lines here will never meet, just like what parallel means in math class. Once again, benefit, if one goes out, the other stays on. Moving on to number 8. Number 8, sketch a circuit diagram for a short circuit. Well, actually, let me just recreate my drawing. So this is that same parallel circuit from before. But let's say some water drops down on this circuit. Here's some water. And then gets splashed on here. And splashes in such a way that we've got a whole connection piece from this side to this side. That gives the current a new path. And it's going to get to here. It sees those 2 bulbs up ahead and knows there's going to be a lot of resistance up that way. So instead, it's going to take the easier path straight through the water and then come back and just continue that route over and over again. But this sketch is a little all over the place. So let me shorten that down and clean it up. I could instead depict this as a short circuit by just drawing a line. That's the official way. That's what we want to see. Because again, now the current can flow up, finds this short path, and that's all it'll do. It'll completely ignore those bulbs. And number 9, what's the key difference between an open circuit and a closed circuit? Actually, let me bring an open circuit. The current would be 0. 0 amps, no matter what. This closed circuit, the current would be greater than 0. In other words, in an open circuit, there's no electricity flowing, so that's not of much use. A closed circuit, electricity is flowing, so then we can actually put that circuit to some use. And that's really all there is to it. There is a bonus question. That bonus question will actually probably stay for tomorrow, so as you're preparing, be thinking about a cheesy joke about electricity or circuits. But that is all. Best of luck to you tomorrow.